It's awesome, Andrew, that you sign in from the class.
I see the coding better. If that's
Yeah, no, it's cool. It makes me feel like there's more people in the online audience. Good morning.
Morning.
Brendan and Robert. Okay, let's see, where am I here? I need start.
Is it centered? Keep like saying we'll sit there as I know. Yeah, I mean that like plasma wise thing, like saying that's I think it makes it good for what's called connected integration. I need to use that word. That word's a free 10 point. That's it.
All right, what I want to do today is go through our first example of a neural net in I wanted to start this. There we go. In Keras. So first of all, what is Keras? Keras is it's a library or a framework. I don't know which word to use here anymore. But I think it would, oops, there we go.
Did you post this online?
I think I did, yeah. There should, under content code or code examples, there should be an IPYNB file called, I may have called it something else, but for me, it's called first Keras example. Let me know if, let me see. See content. Oh, this is the wrong course. Guess not. Okay, hold on. So weird. I thought I just did. Okay, I'll put it up now. I definitely want you guys to have it. There. Okay. See what it looks like. Oh, it's 16 kilobytes. Wow, ton of overhead. Okay. I guess not. Right. So this, I'm working in Jupyter Notebook. I was really hoping to run this in Visual Studio Code, which what I'm learning as I learn more and more software tools, that Visual Studio Code is Pylance. Why is it using Pylance? Anyhow, Visual Studio is like super and it's free, I believe, for everyone. And so it's has a lot of cool features like for just project management and bringing in third-party libraries. But we'll stick with Jupyter Notebook for now. And whenever I want to inspect a specific variable, I will just make a new cell and type in that variable and see the output. Am I sharing? I'm not sharing. Okay. So hopefully you guys all see my how do I get rid of this taskbar? Is there a way to do that? Sophie, do you by any chance have your charger again today? I better plug it in. I can feel this thing it's at 48%, which should be enough, but I can just feel by the temperature of my chassis that it's going to be like 20 minutes. It's outrageous. I don't understand what my computer is like. I haven't been doing. I haven't even started the computation. Thank you, Sophia. If you were taking the course for credit, I'd say you're getting extra credit. When you audit the course, does it show up on your transcript? No? Oh, that's too bad. I feel like it should show up. Okay, so first of all, what is this example? The example is sharing recording, yes. The example is image classification. So remember I told you guys that a lot of the advances in deep learning have come kind of in the context of images. Why? Because that was like one of the first like big problems that if solved would have like, you know, implications for the real world. So like the USPS uses convolutional nets, which this is actually an example of a convolutional net. I'm gonna teach you convolutions in lecture 9, but I want to give you the example first because, you know, there's been too much theory recently. And so the US Postal Service uses convolutional nets like this to read the postal codes. And so everyone writes their digits differently, and some people's are very neat, some people's are not. Like me, you can see when I write on the board, it's kind of a disaster. And so it's a difficult problem to translate an image of handwritten digits, and I'll show you a couple in just a minute, into the corresponding digit. You know, there are 10 digits, right? So this is a 10 class problem. But before that, we're gonna have to bring in these libraries. So NumPy, as you know, is just a linear algebra package, an array package in Python. Basically, you will always need to import NumPy. Keras is it's in TensorFlow, I guess technically, but it really sits on top of TensorFlow. It's like TensorFlow is like, it is the guts of deep learning. It's like Google framework. And Keras sits above that. And TensorFlow, the problem with TensorFlow is that to use it, you literally have to construct graphs, like, you know, multiply two numbers, like simple operations, or like have like a graph structure. So you don't want to impose that on the programmer. So a library like Keras comes along and lets you write your code in using this high level API that calls TensorFlow. And then so here we're importing Keras, and then we're also going to import a specific class. I think this is technically called the class called layers. Layers is a class that lets you actually define your network, and it's so a layer is literally like one layer of your neural net. So a layer can be like it can be an input or an output or a hidden layer, and there's probably other things that are subsumed within. Oh, and the problem with this is that every time this happens, the screen shows. I wonder if VIA is installed in this class. Okay, so I'm gonna execute the cell, which I just recently learned on Mac. You can just do Command Enter, and now you see it's running because there's a little star here, and we have to wait for that star to disappear before moving on. It's a big import. Keras is very big. Layers is very big. That's why it takes a while. And so now, remember, no news is good news. So now we have the libraries that we think we need. So this is an important cell. So I'm going to try to, let me see if I can split this up maybe. So insert cell below. Let's see if I can put this here.
So how would you deal with the error that says?
Uh-oh.
Oh,
So did you, what's the error?
no, it just says no module name
That's the error that I had in Visual Studio. You have it in, so do you have Anaconda installed?
Yes. So you did content.
Oh yeah, go to your terminal.
Mhm.
We can debug this on the fly, because I mean, it should just take a second. What? So go
Did you
to,
mean this?
go to your, no, your, terminal. Yeah, just type terminal and see if you can, yeah. And then, type in conda install TensorFlow or pip install. Hold on. Yeah, try, here, let me try.
Yeah, go
quickly. We're just gonna see if we can. I think he usually says if it already exists, it usually tells you if it's there. So, oh, you know what? TensorFlow is a huge library system.
Yeah. It's
What's it
taking
saying?
me a long time.
But it is going through, or maybe pip install.
It's your content, because the new update.
It's still young.
But is hers is it's saying
To fail the
Failed.
I think it does it again afterwards. You have to-
oh, have you done
I
this
haven't used it.
previously?
Literally,
Oh,
I
okay, you
have
haven't
the
used it
sections,
yet.
like the next section.
But there is another way actually you can run this. If you go to well, you minimize this and let this run in the background,
Okay.
but you can open up Spider. So just launch Spider. And then, so actually this is true for, if you guys also have Anaconda installed.
Yeah.
There's an ID, there's a link for Spider, SPYDER. If you open that, because it's really much, watching it is not as good as being able to run on your own. Dismiss that. And then don't copy the file,
Mhm.
just by any chance, is the notebook copied on your download from Blackboard yet?
This?
Yeah.
This code that we're
Yeah.
running? Yeah. And then we do.
Can you open it in like a, we'll try opening it here, I guess.
The first Keras example.
Yeah. Yeah, because that's the that's what the Python notebook looks like. That's what it actually looks like. It's just that the Jupyter knows how to render that. Let me see. You know what? I have an idea. What I'm gonna do is I'm gonna copy my code over to a .py file. And that way, same thing for you guys online. What I'm gonna do is we're just gonna, if you don't have Jupyter Notebook running, you'll be able to run it. Let's see. I'm gonna make, let's see. Let's see how smart Visual Studio is. Let's see if it will let me cast this to a .py file. Save as. Let's see.
So the old content tells me this.
And so the reason that we didn't have this problem, when I gave the logistic regression example, the reason that we didn't have this problem is because, so it's a TensorFlow issue. It's a TensorFlow issue, not a.
Downloading with Conda instead of pip is better for performance.
Oh yeah,
Yeah, so
okay.
if you download it with pip, you should uninstall it and reinstall it with Conda.
Oh really? Because I
I
definitely.
mean, according to this graph that this guy made, I have no idea. I'm believing this the minute I found this.
So pip
I'm already
install.
on it. Conda install is the good one. It'll take longer, it won't be as functional.
Okay, so what I'm gonna do is, why don't I just,
Now it says that the reason why it stopped is that it found conflicts, and it says the following specifications were found to be incompatible with the existing Python installation in your environment.
When was the last time you took that?
No,
probably at the beginning of the core.
so,
No, but that's,
so Honda install. If you download it,
Either-
Honda, I guess.
You don't know like Python from the website, you use like the local.
so, Robert and Brendan, the notebook file is on Blackboard, but what I'm doing now is I'm trying to convert the notebook to a .py file. So that everyone can, and the code is not long, so. It won't be difficult to copy. Oops. Uh, mm, First things first, let me see if I can run. Save as. Okay, let's run it. So again, Spider proves to be the most robust. So what I'm gonna do is post this file, the .py file to Blackboard. And then I'll just run it like as an interpreted mode. Okay, so It should be there now. Just grab the first Keras example for spider version. And I will shut down Anaconda so that my computer doesn't burn my thigh. And don't restart that kernel. That's awesome. Bye-bye. Okay. All right. So let's see. Oh, more technology problems. Let's see if let me first see if by any chance VIA is installed. Does anyone know VIA is installed in this classroom? You don't know, or you don't think it is? Okay. Steinman 560. This is 560, right? This room? Yeah. Right. Let me see. Can you guys take a look maybe if just to make sure that the other end of this thing is in there firmly? I'm sorry, Asia, you're gonna. It is a very long cable. What's weird, again, as usual.
Well, I'm just gonna do this.
What did you say?
I'm getting the same number.
Same error? Okay. So, okay. Okay. Try Pippin's. Okay. What's weird is I thought that Anaconda. Okay, so when you open up Anaconda. So I wonder, like, this this screen may let you install TensorFlow, like graphically. And I think I already did it. That's why I'm not getting, I don't know. Let me actually see. Well, I think what I'll do is you Mylan, your Windows?
Yeah.
Okay. You just need TensorFlow. I mean, TensorFlow says to use pip for what it's worth. Oh, wait a second. There is another option. Google Collab. No installation of anything needed. Let's try that. Sure. Well, I can also, there's less of us today, so we can, if you grab a, oh, okay.
Yeah. We've installed TensorFlow.
Is it working now?
I mean, we didn't even know.
Oh, we're not in the. Just press enter. Yeah, right, so over here, that's where I put
It
it.
starts.
Back. I think the condo one's not working, so she said it was. Find it. Mine just failing a little bit. So you're still up with that one? This is when you find it from?
Let me see. Let me try this Google Collab.
If I copy or something? Okay. That's all. And the TensorFlow too, we're getting the old TensorFlow.
If it,
It wasn't working. I pressed the enter button and now it's down.
it's downloading, okay.
I don't know. Someone's getting up in space.
So let me try this Google Collab. It doesn't require any wow, man, looks slick. It works, man. This is awesome. No, and this is running on a, well, it's running on the cloud, but it's running on their GPUs. If this works, it's awesome. Yeah, it works. The big problem with this is that if you have anything that, well, you need internet, but also there's a possibility if you're like leaving stuff running overnight is problematic because like if there's like you can lose your work. Yeah. But this, I don't think this requires any, has no dependencies at all. If you have a Gmail account, you can just open up a Google Collab window in the browser and then and that's it. And just write code, import whatever you want. Basically import any library that exists and Google recognizes. Okay. I'll give Emilcar a minute. The poor guy's gone to look for a cable for me, and we have a cable. It works now. It's working, but keep it here because it's gonna fail. So I'm gonna try to run this on. Thank you. That's fine. I'll stand with my laptop near the projector if I have to. Okay, so all I did in the cell above is just, this is hilarious, this warning message. This is literally, this code is literally from Keras' API. Okay, I've just brought in NumPy, TensorFlow, Keras, and layers. And so now what I'm going to do is I'm going to bring in my data. So the nice thing about Keras is that they have a whole bunch of data sets built in. So for learning purposes, you don't have to, like in old days, like it would be a struggle just to get you some real data. But now Keras comes with a whole bunch of real data. And so what this cell does, this is just a definition of how many classes you have. So that there's 10 classes because there's 10 digits. So the classes are 0 through 9. And then the input shape. Remember I said it's called TensorFlow because they're literally, you're propagating tensors up. So the tensor, well, there's two definitions of a tensor, but the definition of a tensor in computer science is it's just a multi-dimensional array. So it's an array that has more than 2 dimensions. So the reason that even though it's really just a 2D array in this case, because these MNIST images that we're going to be working with have 28 pixels in the row dimension and 28 pixels in the column dimension. The reason that this is explicitly the page dimension is explicitly initialized as a 1 is because most images are RGB. And so you have the third dimension is your color dimension. And so if you had, if you had color images, then the third dimension would be something like 3. Okay. I love this data type in Python, these tuples. So this is, I was hoping to have more time, but I really hope that you can understand this notation here. So, okay, Keras is like I'll write this as a comment. Keras is like your top level. And then within Keras, is a library. And then within Keras, it's really probably a class called datasets. And within datasets, there is a class called MNIST. MNIST is this handwritten image dataset. It has, I think, 80,000 images or something. And then within MNIST, there's a function called load data. So this is, and then it's a function because it has the parentheses in it. It's empty because it doesn't need any arguments. So load data by itself will bring in the data for you. And the cool thing is that if you specify these 2 arguments, it will partition the data for you into training and test sets. So it's extremely convenient, for testing purposes. So let me actually do what I did before. I'm going to copy and oh, I want it here. Okay, so you see it's downloading from the web again. This is like when I was in school, this would have been unheard of, the idea that you can run a piece of code that connects over a network and actually grabs data for you. It's wild. Okay, so now let's look at, hopefully. Okay, so now you see, oops, what happened? See the shape, right? So the first dimension is always going to be, it's back. The first dimension is always going to be examples. So the training set has 60,000 examples. And the next 2 dimensions are your features. Notice that the features, we could have made this as, is this 576, 28 squared? Is that what it is? I don't know if it is, but we could have made this to be 60,000 by 576, but we didn't. And there's a reason why we didn't, because the kind of learning that we're going to do here is actually going to learn in 2D. It's not gonna do what's called flattening the vector, flattening the array into a vector and then learning on one long vector. It's actually going to work in a 2-dimensional space. Why? Because there's information there. It can learn things in the native pixel space. It can learn patterns. It can learn 2D patterns, basically. And then let's also print out, let's print out all of them. I'm not sure if they'll all print out, but hopefully just so that we know what we're dealing with. Okay, so it only prints out the last one. Yeah, so now that's what I'm about to do. So what you're gonna see is, I think this is like a 3-to-1 split of training to test, or no, not 3-to-1. There's only 10,000 in training in the test set here. So this just means that the labels, basically comma nothing in Python, what it does is if you say, oops, why this is, I wonder if this is my computer. Give me a second. I'm gonna close mail because it's saying somehow my mail client is using a lot of power, which I find hard to believe. And then,
It was with your monitor, no?
mhm.
So,
Yeah, but it has to, no, but the video, like the video, you know, there's putting you know, I think when you connect to an external, it has to render, it has to send the video to 2 different channels, right? Let's try again. Oh, yeah, that's useful. Let's try that. You know, I'm cheap, so I always buy the cheap, you know, Amazon's Choice or whatever. Do you think merchants pay Amazon for them to say that? Or do you think Amazon is choosing?
so
No, give it time. It may work still. Mirror displays. Okay, so it's not the, do you want to try, let's see, this
new
is,
table?
yeah, well, give that, this is Sophie's, right? Thank you, Sophie. Let's try once more, and then if it doesn't work, then, what's that? Switch to PC? Yeah, no, I could. I mean, I could try, I mean, definitely a different computer. I mean, I can feel that my computer is very warm. Not sure.
We also just joined the Zoom.
Yeah, do it too soon.
Yeah, yeah, you guys can all join the Zoom. That would be the, I don't know why it's not. What's using a lot of power, display brightness. How do I change display brightness without access to the Genius bar or whatever they call it? It's usually here, but now that okay. Admit all. Okay, so think we're all in. Now I will. All right, you guys see my you guys see my window? Okay. Well, we may as well be at home now. All right. So I've loaded in data here in this cell, and I've looked at the shape of the data. And so now, so the data comes in to make it, to make the data set as small as possible on disk. They're stored as integers from 0 to 255 because intensities are, they're positive. There's no such thing as a negative intensity. And so this cell here will just take all the pixel intensities. First, the .as type is just like a native Python function that lets you change the data type. So unlike MATLAB is cool because you don't have to really worry about data types. Python's a little bit more strict with data types. So like if you try to perform an operation that isn't supported by a data type, it will error around. I guess MATLAB will do that too in most cases. But here, all we're doing is we're converting those integers into floating point numbers, and we're dividing by 255. So we're just normalizing everything to be between 0 and 1. This is just, this expand dimensions. It's just to make sure that our boy, I may as well look at his photo. What was that?
I get one.
You didn't get one?
AT&T?
That's concerning.
Yeah. AT&T is always 5 minutes after.
I guess it's still manager. That's all. That's a bad joke. Oh, sorry. It's like the person from this one. No,
You know who it is?
Yeah, Frank James. Man, 62 though.
that's what I
The
said.
golden years, man.
Not quite good. No, I was like, what they're supposed to be. Oh, 62 is pretty good now.
Yeah, well,
Yeah, but like in the subway, if I saw a person who looked like 62 years old, I wouldn't be scared of them. I'm like, no man. But no.
yeah. Hello. You guys know the story of Echo? Like the mythology story of Echo? It's Narcissus. Is that his name? Narcissus, I think, is his name. Fell in love with himself, hence the term narcissism. And so he looked, I guess, into a lake or a pond, and he saw his reflection and he fell in love. And I guess Echo is, I'm not sure, isn't Echo the name that he attributed to the woman that was caught, that I think when he spoke or something, the sound came back in. Isn't that Echo? I think that's the story. I'm gonna look it up in a second. But Echo and Narcissus. Hold on.
Probably like Narcissa or something.
No, it's no. He's Narcissus. Like
Narcissus. That's my freak.
I wish my memory wasn't so bad, because this is actually, I remember reading this story recently because we were reading these stories to my younger daughter, and yeah, Echo and Narcissus, myth from Ovid's Metamorphoses. It's actually a Roman mythological epic. The beautiful youth who rejected Echo. No, he rejected Echo and fell in love with his own reflection. I don't know. It's pretty deep for 2,000 years ago. I mean, Lord knows we have a lot of narcissists in today's society. So the story is absolutely applicable.
Alpha power thing,
What's
whatever
that?
they call it, like the alpha man or
Uh,
what is it?
Chad,
No,
I think it's Chad.
like that whole idea with men have to be like the
Oh, the alpha.
alpha male.
You know what I read? You know what in Steven Pinker's book? I think it's one of Steven Pinker's books. He talks about this.
Morality one, which one is it?
No. I think it's one of the earlier ones. What's really interesting is the guy who came up with the alpha male, he was studying, I think it was bears. And he noticed that like there was always like one bear that dominated the other. And so
It's not lions.
maybe, I don't know,
Lions are
maybe
big,
lines.
yeah.
But the thing is, it was a mistake. And he actually acknowledged that it was a mistake. It was like parents and children.
Oh.
It wasn't in the same generation. And so his finding has now carried over into like society with like alpha males and beta males. But it was actually a mistake, which is really ironic, right?
Wow, but doesn't that exist in other species? Like
Maybe.
the same generation, but also have like a pack leader or whatever. But there was a podcast that there was a scientist who studied evolution, and one of the reasonings why human beings have been much better as a species or have been more complex is because all other species they believe in alpha males and they have dominant males in their whatever
Right.
in like their population. And in society for so long we have tried to like not have alpha males as in not have them their leaders just because they're alpha males. So that's the whole idea why it's a bad thing and people shouldn't believe it. But then again, you have like conferences when like young kids go and pay money just to get like someone to tell them that you should be an alpha male. and not a beta
Oh
male.
yeah, like
It's
the
just
Jordan
a thing.
Petersons. Yeah. Well, I mean, those guys are capital. Yeah.
Yeah. So
Yeah. Well, I think that there is a market for sadly, there's a market for frustrated young men, sadly.
mhm.
And the thing is,
It's so sad.
what we need is like we need different voices, right? We need different voices that like we need more positive male role models. We need someone other than Jordan Peterson, um, advocating for these men. But the thing is, who wants to do that job? Jordan Peterson was a psychology professor at University of Toronto.
He got fired.
Did he get fired?
He
No,
got
I don't
fired
think
from-
so.
Did you?
No, I don't
thought
think
he did.
so. No, I don't think he got fired. In fact, I think that university's a business. They probably love him.
Oh, like there was like so many like protests of like first students.
Yeah. All right. Let me get through it. We still have 18 minutes, so we can actually what I want to show you here first, the first thing I'm doing in this cell, and the comment, you guys still see what I'm doing, right? Okay. All this is doing is just two categorical is just it's like a helper function. So if Y train comes in, I think, right. So I mentioned the one hot encoding. And so let me actually, what I'll do is, why don't I demonstrate? Let's do Y train of 0. So remember, Python indexing begins at 0. So Y train 0 was a 5. And what if I go keras.utils? Come on, no autocomplete. Oh. Doesn't work. So remember, the label is a 5. And see, now it gets but this has to have, you have to specify how many classes. So this is like a one hot encoding. This is Keras's version of a one hot encoding, right? So you see that it's okay. That's what made me think of Echo narcissist, by the way. I wasn't just thinking about it this morning. Right, so you did the sixth element is a 1, right? That's the class corresponding to the digit 5s. And so that's what we're doing with the labels here, because what the network is going to do, the output layer, the top layer, is not going to have 1 node, it's going to have 10. And the node that has the highest value becomes the predicted label. So in this case, we want the 6th output node from the left to have the highest probability. Okay, and now what I'm going to do is I'm loading in some plotting functions from an library called matplotlib. And what I'm going to do, all I'm doing here is I'm just going to render, I'm going to pick a random image. So this is, remember, we're picking a random number from 1 to 60,000. We're rounding it up to get it to be an integer, and then casting it as an integer. And then I'm going to take that image, the 28 by 28 pixel image, I'm going to plot it here. So hopefully this works, because I didn't test it in Google Colab. Oh, what's the error? This works in I think this works in Spider, right? Which is really weird. It didn't plot though. I want to make a cell. I guess I don't, it's not the end of the world if I don't show you the
I don't think that's a cell though.
no, I don't remember how to do
A
cells.
cell is like hashtag and then 2%.
There you go. Thank you. Okay. Where's the figure window? Okay.
You have plots, but I don't think you plot anything.
No, I did.
It's
Plot.imshow. Oh, there it is. Okay, so that's what it should look like. I don't know why it's not working in Google Colab. So I'll apply you another random one. That's a 6. So these are the scanned 9. Do one more. Yeah, like, right? So you see, yeah, that almost does look like it's upside down.
It is.
There's always tiles in
It is like the.
What's the error? That's nonsense.
But actually, before I noticed when I was running the code to do the shape of the X string, I would get like 600, 28, 28, and a 1 at the end.
I see. It must be using a different. Oh, you know what it is? Probably there's things that happen like I'm running this in the cloud, and so it's grabbing the current versions of the libraries on the back end, which are not the same versions of the libraries that I have on my local machine. And so it's okay. Let's see, what is it saying? Too many indices for array. It's saying,
Three-dimensional.
there. That's weird, dude. That is weird. It doesn't like the fourth. It doesn't recognize the fourth. Google Colab does not recognize the fourth dimension.
But it says 3/0.
Oh yeah. What is IDX? That's weird. Let me see what print IDX is. Let me go. Let me actually just run everything. You know what? You guys, it actually, why don't I just run it in Spider then? Because you guys, we're not, it doesn't matter, right? I mean, I may as well just run because,
If you're just showing us, you do it by that too. Do it,
yeah, that's what I'm,
I mean, you just do it in.
what's weird is
Right with Jupyter Notebook, it's-
the exact same, or Jupyter Notebook, yeah.
That's already nicely written out.
Yeah, let's do that.
You try that, maybe?
So weird. The same code. Let me at least, what I want to, the thing that I definitely want to get to is, I'll just run this from the beginning. And here's, I don't want to, so here's an 8. Here is a 3, okay? So we're there. So this is the part that I want, this is the most important cell. This is where you define your model. And this is what's made deep learning accessible for everyone. You literally define your model as just like every line is a layer in the model. It's crazy easy. So the first, obviously the first layer is your input. And the only parameter that you need is your shape input. So that we already defined the input shape. It's 28 by 28 by 1. And so now your model, which is coming from the Keras sequential class. Sequential just means one thing after the next, which is, so one row after the next. So that's our input. So this is, you'll often see these conv2ds, conv3. This is called the convolutional layer, which I'll teach next week, or I guess next week is spring break, so you'll be in Cancun or whatever. But I'll teach when you're back. And so what this, right, so what is this doing? So it's basically, what I'll do is I'll do this on the board. So I do want to tell you what a convolution is because it's actually super intuitive. And that way you'll know what this network is doing. So if you have an image that has a certain number of, so what a convolutional network or operator layer will do is it will basically take what's called a kernel, or you think of it as a filter. Think of it as like a two-dimensional filter. And it basically, it multiplies, so it's a filter that slides across the image. And so let's just say there's no overlap. Next it will go there, and next it will go there, next it will go there. And at every, and what it's doing is it's multiplying this kernel. This kernel has 4 numbers, and every time it goes over a section of the image, it outputs, a number for the next layer process. And so the key thing is that, with before convolutions, you would have just one big filter that would have as many weights as you have pixels. But what the convolution is doing is it's taking the same filter and it's just tiling it across the image. And the reason that works well, these are not zeros, these are nodes. These are basically nodes in the next layer. The reason the convolutions are useful is because in images, we don't know where the objects are going to be. And so you can think of this as like you can think of this 2x2 filter as like an object detector. that is being slid across the entire image. And so it's called a convolution because it slides, and it's kind of it's basically multiplying and then adding, which is what a convolution is. It's not exactly the same kind of convolutions that you learned in like signal processing, but it's very close to it. And so the so that convolution, the 32 here means that the output size of that layer is 32, which means that we're taking our 28 by 28 image, which is 576, and we're distilling it down to 32 numbers. And each of those is an output of one of those convolutions. So we essentially have 32 filters. Each of them is 3 by 3. So if you multiply 32 by 9, and then there's an intercept, so there's and plus an intercept, so 32 by 10 gives you the 320 parameters here. The max pool, and then this is that activating function that we talked about. It's just a nonlinearity added to the output of every one of those convolutions. Max pooling is all it's doing is if you have like 4 pixels, max pooling just takes the maximum value. It's better. It's again, a max operation is nonlinear operation. So we could do the mean. I think conventional image processing algorithms would take the mean across a set of pixels, but max pooling it's instead of doing a mean, it's taking the maximum value. The idea is that if there's something in the space that's really important, it's going to have a large intensity. So pick that one. And then the next step is just another convolutional layer. So, we're essentially, the output of the first convolution here, which you see in the model summary, try to show you both, is going to be 26 by 26 by 32. And then the second convolutional layer comes around and it brings it down to even a smaller size, to a size of 11 by 11 by 64. So the second layer is using more convolutions, but the shape of the image is getting smaller and smaller. And then you do another max pooling layer, which brings your image down to 5 rows, 5 columns, and 64 filters. You can think of a filter as like a feature. Basically, what each of those convolutions is doing is trying to find something in the image that's high level, that's important. And then flatten is it just takes the 5 by 5 by 64 and it collapses into just a big vector. And then a dense, don't worry about the dropout, it's just a way of regularizing the model. And the dense operation means that another word for dense is fully connected. So literally means connect every node of this layer to every node of the next layer. And every node of the next layer is the output, which is the 10 nodes. So you should see that 1600, there's 1600, the 1600 comes from, it should come from 5 by 5 times 64, is that 1600? Yeah. So the 16,010 connections here comes from, there's one connection between every one of those 1600 hidden units to every one of the output units, and there are 10 output units in this example. So our total network has 34,000 parameters, which is okay because we have 60,000 training examples. And now what I'm going to do is I'm gonna run this, and you're gonna, oh, I haven't run the previous, so I'm gonna run this, and I'm gonna see what you're gonna see what training looks like. Epoch is a pass through your data set. So because neural nets, the cost function that is being minimized is non-convex, you don't always get to the bottom of the hill the first time you pass your data. And so you start again, and every time you start, you're starting from a different point in the parameter space. And at the end of these 5 epochs of optimization, it's gonna pick the best solution. So when I say best solution here, it means the one that does the best job of classifying the training data. So there are 60,000 examples in the training data, and you're seeing that as it goes, the accuracy should get better. And you see it is mostly getting better. So it's almost on the 5th epoch. You see the accuracy at the end of the 5th epoch is close to 99%. And then to actually, this is kind of the fun step. This is where if you're playing with your data, this is ultimately all that you care about it, is you want to evaluate the model that you just learned on your test set. So you run that. And then, so evaluate is a function, is a method or a function of the model class in Keras. And model has all the coefficients of our neural net. So it knows how to take our feature vectors and make a prediction of the label. So you see here that it predicted the test set with a 99% accuracy, which seems trivial. And if you look at these images, like, yeah, of course, this is easy. Like the information is all there. Well, 10 years ago, the state of the art was like 90%. And so what's allowed this progress are these convolutional layers, which I will teach formally in 2 weeks. But what I wanted to show you today is just how to construct the model. So you construct a model by literally saying, this is my input, then your architecture, and then my output. Fit, evaluate, and then you're done. I encourage you to try to play around with these, with this example, and there are other examples that I'll show you. Keras.io has lots of examples for you to work through. Okay, guys. I wish you a good nice spring break. Bye-bye, Robert and Brent.